Dear students, as we talked today in the class of the concept of using softwares such as Excel software to solve the linear programming problems, I repeat in this video how to do this problem and find the final solution based on the problem in two different types of solution. First of all, we learn how to use the formula sum product, or in Spanish form suma producto, and then we review a little bit of adding solver to see how this one works, where should we install that, okay, and how this one calculate the solution. Okay, as you remember, this is the prototype example that we have in our presentation, Windoor Glass Company product mix problem. So, as you remember, it's about producing two products, doors and windows, in by using three different plants. And obviously, as we know, these three different plants has the availability. For this reason, the sign of their constraints are less than or equal. Besides, we know the profit per production of door, each batch is $3,000, and for Windows, it's $5,000. So, based on this reason, as you see here in the right-hand side, the objective is maximizing the profit per batch, okay, of these two products, subject to these three constraints that we have, while the variables are greater than or equal to 0. First of all, let's review to create each of these constraints in some simple formulas. To this end, as I told you, we use a formula that is sum product. For those who are not that much familiar with Excel, I tell you, in Excel, for all of the formulas, we should start with equal sign, as what we do here. As you know, guys, we have one objective function and three constraints that we should make the formulas. Exactly what we have here. Let's get started with the three constraints that we have. Three constraints, okay, as you see here, guys, are formed from one side, these hours used per batch and the number of the products that we know they are, for example, X1 and X2. And our objective is finding the X1 and X2 that maximizes this total profit that we'll talk about it later. So, sum product, as I told you, equal in your laptops or computers, maybe if it's in Catalan or Spanish, you find the formula like this: suma producto. So, as you see, if I double click on it, suma producto. So, guys, always the formula helps you and tells you what should be the form of formula. So, as you see here, because in this example, we have from one side the hours per used and the other side per batch, and the other side the number of batches. So we have in total two matrices. But if this problem, for example, for what was for another type of calculation, each side with three elements, we needed to define three matrices and so on. But at this moment, what do we do? For example, for defining this one, the first constraint for plant 1, as what we have if I translate it to mathematics, is 1x1 plus 0x2. So from one side, I should define for my formula this 1 and 0, and from the other side, I should define for my formula this x1 and x2. So I click on this, on this 1 and drag it to the right. As you see here, the formula up shows the 8 double point E8. So it means that select the range of data that are in this range, D8 to E8. If it was bigger, we needed to select that range. Now, we selected from one side and we need to define another matrix. Today in the class, I told you in the computers of EUS, we use semicolon. But, for example, here in my laptop, the Excel works with comma. So, check whatever is possible for your laptop and working for your laptop, or semicolon or comma. Now, from the other side, I should show the amount of the production. So I tell Excel where use the data. So what are these two variables? These two cells of x1 and x2 that we want to have. So do we have something else? No. We close with parentheses, and as you see here now, if I click on this 0, as you see here, summa producto from one side D8 to E8, and from the other side D13 to E13. I should do exactly the same for the second and third constraint. Equal summa producto, double click, okay, from one side this, and from the other side these two variables of the decision variable, and finally the third constraint, these two from one side and these two from the other side. So what is the problem here? Let me see. D10 to E10, D13 to E13. What is the problem? Let me see what happens here, guys. Let's do it again. Summa producto, okay, these two, and these two. Okay, so now we have defined our three formulas of the constraints. So what else remains? The cell, defining the cell of the objective function. What is the objective function? As you see in the right hand side, is profits per batch multiplied by batches produced. So from one side, these 3 and 5, from the other side, x1 and x2. So exactly the same I can do for my profit, total profit. Equal summa producto, okay? These two elements and these two elements, okay? So I exactly defined all four formulas that I have, three exercises, three constraints, and one objective function. So this objective function obviously could be whatever. In this problem is total profit. So now, guys, we know our problem has a solution, has an optimal solution, 2 batches for doors and 6 batches for windows. And as you see, our final result, our maximum profit is 36. And this one is optimal solution. As we talked before about optimality, optimality becomes after feasibility. So a solution should be a feasible solution, then it could be an optimal solution. Why if a solution is optimal? Why all of the constraints are correct and none of them are violated. If one of them is violated, the solution will be infeasible. Like something like this. Check this one. For example, if I put here 4 and 8, for example, as you see, at least one of the solutions, okay, here are two, one of the solutions are violated. 16 is not less than or equal to 12, or 28 is not less than or equal to 18, even though the final profit is more, but always it should be full fee and it should be calculated based on the amount of constraints and what the constraint says. So this was our question. But as we talked before and as we saw in graphical solution, this solution is a solution of trial and error solution. So should be another better solution, okay, should be another better solution to solve it internally, the software. So yes, the solution is applying the add-in that we define in Excel, that is solver. So what should we do? Easy. Step by step, we should follow the problem and I will teach you how this one works. First of all, let's change these elements to 0, the x1 and x2, because we want that solver calculates this 2 and 6. Let's do it. To start this procedure, first of all, we need to install, if it's not installed in our computers, the add-in, the solver add-in. Where is it? The add-in of solver easily can be found. First of all, we should click on this part, Archivo, or if you have English in your computer, file, the last item, as you see here in the left hand side, opciones or options, click on it. You can see a window here, new window opens. So again, in this column that you have in the left hand side, the one before the last one is complementos, or in English is add-ins. Click on it, okay, and in the middle, as you see here, the last line is administrar. By default, the first item that you see is complementos de Excel or Excel add-ins. There are other items, but we don't use them and we don't change this add-in. Okay, we remain this one, complementos de Excel, and click on this button here. So as you see here, guys, I already have installed in my system, okay, this solver, but when you open your computers, you may have something like this. You need to click on it, solver, and then click on accept, aceptar. So now you have it in your system installed. What should you do next? To find the solution, where it locates, easily, you need to click on this tab that you have, datos or data. As you see here in the right hand side, there is this add-in solver. If I click on it, there will be a window, something like this. Okay, there will be a window something like this. Okay, so as you see in this window, all elements that we need for linear programming are located in this window. First of all, establish the objective, establecer objetivo. I need to select the cell where the objective located, where I wrote and I prepared the formula. As you remember, I prepared the formula of objective was in this cell, this yellow cell that you see here, H13. So if I click it here, automatically it appears in this line in front of establecer objetivo. Okay, so I give this information to Excel to go to the cell, okay, to go to the cell to calculate the objective function here. As you see here, the second line says for or para. As you remember, I told you all of the problems of linear programming, they are or maximizing or minimizing. In some exceptions, we have the other forms, but for you at this moment, or maximizing or minimizing. As we know, this objective function is maximizing the profit. So we don't touch it and it remains without change. The next line, cambiando las celdas de variables, what should we do? We need to define for our Excel which variable, what variables are the decision variables for our system. The decision variables for our system are those who are represent as the products. What are them? As you see here in my Excel sheet, they are cells D13 and D and E13, and as we defined for our objective function. Okay, so let me clean this one to show you how this one works. So I define as well my decision variables. The last part, guys, is defining our constraints. Okay, to define, as you see here, sujeto a las restricciones, subject to constraints. To add these three constraints here, in the other examples, more than that or less than that, whatever, we need to click on this one, add or agregar. So as you see here, this window shows you a typical form of defining a constraint. The left-hand side of the constraint are those that we have here. We know our constraints are x1 less than or equal to 4, 2x2 less than or equal to 12, 3x1 plus 2x2 less than or equal to 18. So we already defined them in this column F. Okay, so if it was one constraint, we needed to select one, but here we have three. Click on this one and easily drag to down, and you see, guys, here there are from F8 to F10. Let's go to the right hand side and then explain the middle. The right hand side of the problem should be these three elements, as you see here, H8 to H10. And this middle part shows us what should be the sign of the problem. That should be less than or equal. If we open it, as you see, less than or equal, equal, greater than or equal, integer, and the other. We work with integer one in future in integer programming, but at this moment, we left this one as a default that we have, that is less than or equal. So based on this, from left hand side, sorry, in the left part, I defined three left hand side of constraint, and in the right hand side of this window I defined three amount of right hand side, and the sign should be less than or equal. If I accept it, aceptar, as you see here, all the constraints that we have are in this window. These are our three constraints. So obviously, as I told you, you can do it one by one, but this one, if you drag all the information and data, it's easier. So we don't touch anything else. If I click on this button here, resolver or solve, and accept, as you see guys, what happens here, Excel automatically calculates, okay, this solution 2 and 6 while our final result is 36. What is the difference here in comparison with the previous part? So we don't follow a trial and error. Excel internally calculates the optimal solution if it exists. Okay, that here we know our optimal solution is 36. So by this explanation, this class is over. Please watch this video that it helps you for your laboratories in future, and see you soon. Have a wonderful weekend. Goodbye.